Hi, Rachel Mead here, president and founder of Enhanced Prep. Thanks for joining me today while we take a look at this SAT math-based question. Now, we can see this question is starting off by talking to us about the vertex of a quadratic function. So one of the things that I want to do here, just to help you understand a little bit more of what's happening in this question, I'm going to drop in a graphing square just to help again give you a visual of what's happening. Are you doing this on the actual exam? Absolutely not. But it helps me convey the expression of the idea, the task of our job by doing this here for you. So we know when we're looking at our vertex that that's all about the minimum or the maximum and where our graph is going to curve up or curve down. So I know my vertex here is at 2, -7, 1, 2, 3, 4, 5, 6, 7. I think that's 7. Let's go ahead and let's graph that point. So we're going to come over to 2 and go down to 7, 4, 6, 7 right here. So that's my vertex. So because this is telling me that I have x-intercepts, I know that this is going to be curving up. So I know this point is coming in here at 2, -7, and then I'm going to be coming through my x-axis at two different places. Now, one of the things I need students to remember is that the vertex also represents our line of symmetry, which means the two halves of my parabola or the graph of my quadratic are going to mirror each other on this line. I also want to point out, because they're x-intercepts, we know that our y value is 0. But I do need to get this in ways that I can equate it to each other. So since my x point is currently 2, but all of my answer choices are expressing this in terms of a fraction with a 20 on the bottom, I want to turn my x point at my vertex to a fraction that also has 20 at the bottom. And I know if I have 20 at the bottom, I need to have 40 in my numerator in order to be able to correctly express 2. Now, that axis of symmetry means that the x-intercept on one side is going to be equal distance to our x on the other side. So again, I don't really care where this 13/2 is. I know it's going to be really small, right? This is less than 1, but a little bit more than 1/2. So it's coming through right in here. So again, keep in mind that this graph isn't necessarily helping me other than visualize what's happening. But I do know this distance between my axis of symmetry and my point has to be equal to this distance on this side between my axis of symmetry and my point. I'm going to quickly eliminate answer choice A because again, that axis of symmetry is in between the 2 points. So I want to pay attention to this 13/20 in relationship to my 40/20. And my job here is to calculate this distance. Well, these are 27 apart, which means as I'm moving to the point on the other side, these also need to be 27 apart. So 27 more than 40 is going to put me at 67/20. Again, axis of symmetry. Axis of symmetry is defined always, always, always as the line that runs through the x value at the vertex. And again, what does it mean? The points of intercept, the x-intercepts, are equidistant from that axis of symmetry. So that should give you a quick opportunity to come through and solve this. Notice a lot of students might be tempted to use their Desmos application, but we don't have an equation. We just have 2 points. The amount of time it takes to drop in those 2 points and calculate your other side is going to be complex, especially when we're looking at having to trace to such a small fraction. So this is a great example where knowing your applications algebraically are going to help you get to the question help you get to the correct answer faster. Thanks for joining me. We'll see you soon.